So we talked about the properties of metallic compounds. Let's talk about the properties of ionic compounds. Metallic compounds are made of what kind of elements? Metals. Metals. Ionic compounds are made of metals and non-metals. If you take a metal and you put it with a non-metal, you get an ionic compound. Okay. So, for example, very famous ionic compound, sodium chloride. Which one's the metal? Sodium. So, there's metal, and chlorine's a non-metal, so that's an ionic compound. This time, instead of the valence electrons floating freely around among all of them, they are transferred from one to the other, from the cation to the anion. Who's going to be the cation, the metal or the non-metal? So the electron's going to go from the metal to the non-metal. Always. It does never go the other way, ever. Some people will say so. So, watch the animation. Here's my sodium. Here's my chlorine. What's the charge for sodium? Plus one. Plus one. So it has one electron, and it's going to give that one valence electron to chlorine. And that's it. Now the sodium is plus one, and the chlorine's minus one. The chlorine took an electron, so it gave it one.
Those are accidents.
So it gave his electrons and all.
It gave its valence electron to chlorine. It still has 10 electrons left. It gave the valence electron to chlorine.
Does it go back and forth?
Nope, it just goes one way and sticks. And so they have a permanent charge. Okay. Let's talk about some of their physical properties. Ionic compounds are solid crystals. Crystal means it has a regular structure. Sodium, chlorine, sodium chloride. And they have high melting temperatures. What's the melting temperature for water?
100 degrees Celsius.
Boiling temperature.
Isn't it?
What's the melting point of water?
There is none.
Room temperature is
0. Really? You guys know this?
No.
Okay.
We just don't blame it.
On the Celsius scale. Yeah, freezing. Freezing melting happens at the same temperature. Yeah. And you have a block of ice.
How do you
Quiet in the back, please.
How do you
I'm trying to
freeze them
teach.
at the same time?
If you've got a block of ice and you raise it to 0 degrees Celsius, it melts.
Right?
So the melting temperature for water is 0.
Alright.
And the boiling temperature is 100.
Alright.
Okay. Alright. Sodium chloride has a melting temperature of 800 degrees Celsius. If you want to take solid sodium chloride, the salt in your salt shaker, and turn it into liquid sodium chloride, you have to get it up to 800 degrees Celsius. Do not try this at home.
I have a question.
So we can't put it in
Not
the
have a
oven?
hole left.
I can't put it in the oven?
I have a
Does your
question.
oven go up to 800 degrees Celsius?
I just keep it at
That's pretty high.
Thank you.
You have to multiply by 5.9.
Not that high.
What do you have a gas?
Yes.
Is it Celsius hotter than?
Alright. How do you keep it at? Keep it a liquid. Like,
You have to keep it really hot.
dang, because I want to see if somebody.
No.
That would. Hey, bro.
It wouldn't taste at all. It would burn the crap out of your mouth. And then there'd be a hole right through your head.
Hey, John, I like you, bro.
Stacy, you guys are not being very nice to my phone. I'm cold. I have a cold. I'm not going to be here tomorrow. My throat is sore. Vocabulary. When you see this formula, it's called a formula unit. So salts, sodium chloride's formula unit is NaCl. Okay, now let's talk about what happens to size. Wait, whoa. When you gain an electron, you become an anion. And when you do that, you get bigger. So if you have chlorine becoming a chloride ion, it gets bigger. Yeah, chloride. Chlorine, chloride. Conversely, when you lose electrons and become an anion, a cation, you get smaller. So if we have sodium, becoming sodium ion, it's tiny. Now, for the $64,000 question.
Whoa.
Why do the cations get so much smaller than the anions get bigger?
Less energy.
Because of the effect of nuclear charge.
No.
Because electrons will make take up space.
Because of the
Has less energy.
nuclear
Has less
radioactive
technology.
electromagnetic electrons.
Not exactly.
I don't think that's right. So yeah.
Not exactly.
Look.
Valence electromagnetic, making the radius small.
It has less energy. I'm not gonna try.
You're missing a word.
Electrons. That's
No.
ionic. What word am I missing?
What?
Atomic radiation.
Okay. You guys are the closest. This one has fewer energy levels. There you go. It lost an energy level. Did this one gain an energy level? No. Okay. It just added the electron to its third energy level. Whereas this one lost the entire energy level, so it gets that much smaller. Does that make sense? Okay. Well, tell you what, I'll draw it.
Yay.
Bauer, is there a slide that gives us an answer?
No.
What do we write?
So I'm gonna do it.
Okay, here we go. If we have chlorine, it has 17 protons, 17 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17. As far as this unit is concerned, we only really need the Bohr model. We don't need to worry about the quantum mechanical model. Sodium has 11 protons, 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. So they both start off with 3 energy levels. They both start off close to the same size. Which one of these would be bigger to start off with? Sodium. Because how much effective nuclear charge are we feeling here?
Oh. Okay, 11 minus 8.
11 minus 8 minus 2.
2?
So it's still in one.
No, 1. How much is this one feeling?
So that can't be math.
7.
7.
Hey.
Okay. So who's going to be smaller?
So
Chlorine. Because it's pulling its electrons in tighter. Okay, so as far as the neutral atoms are concerned, chlorine is smaller than sodium. However, when chlorine takes sodium's electrons, here's sodium, it's like, I don't want this electron anymore, you take it, and it just puts it in its third energy level. Well, that means that sodium loses not only the electron, but the whole energy level. So now it can be smaller.
But if there was more electrons in it, the whole thing would go away.
Right, if there's still electrons left in it, then it would still be there. dealing with this ionic bonding stuff, there will not be electrons left. The elements, the cations, will lose as many electrons as it takes to lose that energy level.
So what's the answer to this?
Because sodium loses an entire energy level. The cations lose an entire energy level. That's what makes it so small. The chlorine gets a little bit bigger, sodium gets a lot smaller.
I'm ready.
Do you understand? If chlorine was already full, first of all, it wouldn't take the electron, because the goal is to get a full energy level, because that would assume another gas. So to take another one would be silly. Let's do that. Okay. I'm not saying you're silly, I'm saying
What's the answer?
Sodium loses an entire
That was
Yeah,
black.
energy level.
there you go. You laugh. You're gonna go back to bed. All right. Now, let's talk about this lattice. First of all, I want to make sure this is very clear. This is not lettuce. I get that all the time on tests.
Lay tight.
Lettuce.
Okay, it's lattice.
Told
You
you,
don't
see, I'm
eat
smart.
this. Okay, a lattice. A lattice is just alternating stuff. You guys ever, or maybe you have this at your house, you see those wooden cross things, wooden cross pieces that like roses grow up? You have them on the outside of the house, and there's like a bunch of wooden crosses. That's a lattice.
Okay.
It's alternating. Wood, air, wood, air, wood, air. Okay, so you don't want to eat that. It's wood. Okay? In this case, we're not going to alternate pieces of wood with diamonds of air. We're going to alternate positives and negatives. So whenever you have sodium and chlorine, the sodium gives the electron to the chlorine, they now stick together in what's called a lattice, and it looks like this. So we have alternating chloride, sodium, chloride, sodium, chloride, sodium, all the way through. This is not a molecule. There is no such thing as an ionic molecule. Make that super abundantly clear. Really clear. No such thing as ionic molecule. What happens is, okay, do you know what electrostatic attraction means?
No.
It's a very fancy way of saying positives are attracted to negatives. So what happens is the sodium gives the electron to the chlorine. So here I'm the sodium, and I'm giving my electron to the chlorine atom. She keeps it, okay, I never take it back. But this makes me positively charged, and that makes her negatively charged, so we're attracted. So we hang out together. I never take my electron back, she keeps the electron, but because we're oppositely charged, we hang out together. Does that make sense? Okay. Same thing happens here. So because this sodium is positively charged and these chlorides are negatively charged, they're all attracted together, but they're just friends. Okay, they just hang out. They're not attached to anyone in particular.
Oh, so they just
Swingers.
They're friends.
Ah!
They're just friends.
Like Will Smith.
With benefits.
No benefits, just friends. They just all go to the movies, they just all sit together, just all
But do you know what
friends.
we do?
Okay. Because, and why I'm emphasizing this, if a sodium was assigned to a particular chloride ion, then that would be called a molecule.
Okay.
And we don't do molecules in ionic compounds, we're just friends.
Alright.
So molecule would be like the benefit part.
Yes, but we don't do that. Not for ionics. Now, next unit, it'll be all about the molecules. Okay? But this unit, it's just ionic lattice. Just friends. Now, we're going to talk about subscripts. You already know about subscripts. What's the formula for water? H2O. That 2 is called a subscript. Anytime you write a number below the rest of the letters, it's called a subscript. When we're dealing with ionic compounds, the subscripts tell you the ratio. What's the ratio of sodiums to chlorides? 1 to 1. So the subscripts are going to be 1s. Now, just like in math class, we don't have to write the 1s. So it's not Na1Cl1, it's just NaCl. And that means 1 sodium for every 1 chloride. So what if you have, potassium oxide.
Two potassium for every oxygen.
There you go. So 2 potassiums for every 1 oxygen. And we're going to talk about why some of them are 1-to-1 and why some of them are 2-to-1 in a few slides. Any questions about this? Of everything on this slide, the most important topic is this one right here. Little star on that one. Okay, the subscripts and the ratio. Yes.
I was just gonna ask if, we got school.
I will be here after school.
Oh, you're recording this.
Exactly.
Yeah, I'm so slow.
So they're gonna see like the class.
Yeah.
What was the answer to my question on the last slide?
Sodium loses its entire energy level. It's because they lose an entire energy. Alright. Here it is. Here's the objective for the rest of the evening.
I think we should like call it a day.
Alright, stop that.